the climate has always changed, and changed without any help from us humans. We can trace the present warming trend back at least 200 years, to the end of a very cold period in Earth's history. This cold spell is known to climatologists as the Little Ice Age.
Let it snow, let it snow,
If we look back further in time, before the Little Ice Age, we find a balmy golden era, when temperatures were higher than they are today, a time known to climatologists as the medieval warm period. Going back in time further still, before the medieval warm period, we find more warm spells, including a very prolonged period during the Bronze Age, known to geologists as the Holocene maximum, when temperatures were significantly higher than they are now for more than 3 millennia.
If we go back 8,000 years in the Holocene period, our current interglacial, it was much warmer than it is today.
After the Second World War, things changed. Consumer goods like refrigerators and washing machines and TVs and cars began to be mass-produced for an international market. Historians call this global explosion of industrial activity the post-war economic boom. So how does the industrial story compare with the temperature record? Since the mid-19th century, the Earth's temperature has risen by just over half a degree Celsius. But this warming began long before cars and planes were even invented. What's more, most of the rise in temperature occurred before 1940, during a period when industrial production was relatively insignificant. After the Second World War, during the post-war economic boom, temperatures, in theory, should have shot up. But they didn't. They fell. Not for 1 or 2 years, but for 4 decades. In fact, paradoxically, it wasn't until the world economic recession in the 1970s that they stopped falling. The greenhouse effect works like this. The sun sends its heat down to Earth. If it weren't for greenhouse gases, this solar radiation would bounce back into space, leaving the planet cold and uninhabitable. Greenhouse gas traps the escaping heat in the Earth's troposphere, a few miles above the surface. And it's here, according to the climate models, that the rate of warming should be highest, if it's greenhouse gas that's causing it. The first ice core survey took place in Vostok in the Antarctic. What it found, as Al Gore correctly points out, was a clear correlation between carbon dioxide and temperature.
We're going back in time now, 650,000 years. Here's what the temperature has been on our Earth. Now, one thing that kind of jumps out at you is, did they ever fit together? Most ridiculous thing I've ever heard. The relationship is actually very complicated, but there is one relationship that is far more powerful than all the others, and it is this. When there is more carbon dioxide, the temperature gets warmer.
Al Gore says the relationship between temperature and CO2 is complicated, but he doesn't say what those complications are. In fact, there was something very important in the ice core data that he failed to mention. Professor Ian Clark is a leading Arctic paleoclimatologist who looks back into the Earth's temperature record tens of millions of years.
When we look at climate on long scales, we're looking for geological material that actually records climate. If we're to take an ice sample, for example, we use isotopes to reconstruct temperature, but the atmosphere that's imprisoned in that ice we liberate, and then we look at the CO2 content.
Professor Clark and others have indeed discovered, as Al Gore says, a link between carbon dioxide and temperature. But what Al Gore doesn't say is that the link is the wrong way round.
So here we're looking at the ice core record from Vostok, and in the red we see temperature going up from early time to later time at a very key interval when we came out of a glaciation. And we see the temperature going up, and then we see the CO2 coming up. CO2 lags behind that increase. It's got an 800-year lag, so temperature is leading CO2 by 800 years.
There have now been several major ice core surveys. Every one of them shows the same thing. The temperature rises or falls, and then, after a few hundred years, carbon dioxide follows.
So obviously, carbon dioxide is not the cause of that warming. In fact, we can say that the warming produced the increase in carbon dioxide.
The ice core record goes to the very heart of the problem we have here. They said, if the CO2 increases in the atmosphere as a greenhouse gas, then the temperature will go up. But the ice core record shows exactly the opposite. So the fundamental assumption, the most fundamental assumption of the whole theory of climate change due to humans is shown to be wrong.
So the warmer the oceans, the more carbon dioxide they produce, and the cooler they are, the more they suck in. But why is there a time lag of hundreds of years between a change in temperature and a change in the amount of carbon dioxide going into or out of the sea?
The ocean has a memory of past events running out as far as 10,000 years. So, for example, if somebody says, oh, I'm seeing changes in the North Atlantic, this must mean that the climate system is changing. It may only mean that something happened in a remote part of the ocean decades or hundreds of years ago, whose effects are now beginning to show up in the North Atlantic.
The current warming began long before people had cars or electric lights. In the past 150 years, the temperature has risen just over half a degree Celsius. But most of that rise occurred before 1940. Since that time, the temperature has fallen for 4 decades and risen for 3. There is no evidence at all from Earth's long climate history that carbon dioxide has ever determined global temperatures. But if CO2 doesn't drive Earth's climate, what does? Sunspots, we now know, are intense magnetic fields which appear at times of higher solar activity. But for many hundreds of years, long before this was properly understood, astronomers around the world used to count the number of sunspots in the belief that more spots heralded warmer weather. In 1893, the British astronomer Edward Maunder observed that during the Little Ice Age there were barely any spots visible on the Sun, a period of solar inactivity which became known as the Maunder minimum. In 1991, senior scientists at the Danish Meteorological Institute decided to compile a record of sunspots in the 20th century and compare it with the temperature record. What they found was an incredibly close correlation between what the Sun was doing and changes in temperature on Earth. Solar activity, they found, rose sharply to 1940, fell back for 4 decades until the 1970s, and then rose again after that.
When we saw this correlation between the temperature and solar activity or sunspot cycle lengths, then people said to us, okay, it can be just a coincidence. So how can we prove that it's not just a coincidence? Well, one obvious thing is to have a longer time series or different time series. Then we went back in time.
So Professor Friis Christiansen and his colleagues examined 400 years of astronomical records to compare sunspot activity against temperature variation. Once again, they found that variations in solar activity were intimately linked to temperature variation on Earth. It was the Sun, it seemed, not carbon dioxide or anything else, that was driving changes in the climate. Clouds have a powerful cooling effect. But how are they formed? In the early 20th century, scientists discovered that the Earth was constantly being bombarded by subatomic particles. These particles, which they called cosmic rays, originated, it was believed, from exploding supernovae far beyond our solar system. When the particles coming down meet water vapor rising up from the sea, they form water droplets and make clouds. But when the Sun is more active and the solar wind is strong, fewer particles get through and fewer clouds are formed. Just how powerful this effect was became clear only recently, when an astrophysicist, Professor Neer Shaviv, decided to compare his own record of cloud-forming cosmic rays with the temperature record created by a geologist, Professor Jan Weitzer, going back 600 million years. What they found was that when cosmic rays went up, the temperature went down. When cosmic rays went down, the temperature went up. Clouds and the Earth's climate were very closely linked. To see how close, you just flip the lines.
We just compare the graphs, just put them one upon the other, and it was just amazing. Jan Weiser looked at me and says, you know, we have very explosive data here.
The climate was controlled by the clouds. The clouds were controlled by cosmic rays. And the cosmic rays were controlled by the sun. It all came down to the sun. The blue line represents temperature change in the Arctic over the past 100 years. And here is the rise in carbon dioxide over the same period. The two are not obviously connected. But now look again at the temperature record, and at this red line, which depicts variations in solar activity over the past century as recorded independently by scientists from NASA and America's National Oceanic and Atmospheric Administration.
Solar activity over the last 100 years, over the last several hundred years, correlates very nicely on a decadal basis with sea ice and Arctic temperatures.
To the Harvard astrophysicists and many other scientists, the conclusion is inescapable.
When people say we don't believe in global warming, I say, no, I believe in global warming. I don't believe that human CO2 is causing that warming.
The sun is driving climate change. CO2 is irrelevant.